Rafikra Hill University, Dehradun, School of Pharmacy presents this session for the medicinal chemistry, and we will continue with the drug for parasympathetic nervous system, part 5th. I'm Associate Professor Dr. Ahmad Nawaz Khan from School of Pharmacy. In the previous class, part 4, we have discussed the parasympathetic drug classification, and they are directly acting cholinergic drugs and indirect acting cholinergic drugs. And the first class we have discussed was the choline esters, including the acetylcholine, methanocol, carbachol, and methacholine. Structure active relationship, we have done the acetylcholine, and we have studied that there are only difference between the other class, which are the synthetic class like methanocol, carbachol, and methacholine, that they are relatively muscarinic, different relative muscarinic activity, relative nicotinic activity, and different resistance to enzyme hydrolysis. Then we discussed about the some specific cholinesterase drug like methanocol, that what are the structure of the methanocol and how it is formed, where it is acting, what action it is showing, and then carbachol, how it is different than the methanocol, and then in the last we discussed the methacholine. Now let's discuss the cholinomimetic alkaloids. So after the choline ester drugs, these cholinomimetic alkaloids, they are natural alkaloids or synthetic alkaloids. Muscarine, ericoline, pilocarpine, they are natural alkaloids, and oxytrimorine and aceclidine, they are synthetic alkaloids. These muscarine, pilocarpine, oxytrimorine, and aceclidine, they work on the muscarinic receptors, while the ericoline, it works on the nicotinic receptors. Now, how they work? By increasing the tone and motility of gastrointestinal tract and urinary tract. They increase the secretion of the exocrine gland. What are exocrine gland? Just like sweat gland, salivary gland, mammary gland, etc. and mucous gland. And they cause the hypotension and the bradycardia. Bradycardia, that means slow down the heartbeat rate, which is around less than 60 beats per minute. But because all these drugs, they cross the blood-brain barrier, that's why they show some profound central nervous system side effects. Now the pilocarpine is used, which is a drug under this cholinomimetic alkaloids. This drug is used in the treatment of the glaucoma. And what is the glaucoma? Basically, glaucoma is a group of eye condition that damage the optic nerve, and means the health of which is vital for good vision. The damage is often caused by the abnormally high pressure in the eyes, and it occurs generally above the age of 60, and that also causes the blindness. This is the structure of the pilocarpine, and this is the structure of mescaline. There are two salts in which this pilocarpine is available in the market. One is nitrate and second is the hydrochloride. Being less hygroscopic, nitrate is more preferably and easily handled than the hydrochloride salt of the pilocarpine. And now after the direct acting cholinomimetics, there are indirect acting cholinomimetics. They are reversible and irreversible. Let's first discuss the reversible one. So the acetylcholinesterase, which hydrolyze the acetylcholine, is a basically tetrameric protein, and tetrameric protein is a protein with a quaternary structure of 4 subunits, and these 4 subunits, if they are same, they are known as homotetramers, and if they are different, they are known as heterotetramers of the subunits. So this acetylcholinesterase is used for the hydrolysis of acetylcholine. So this ACHE has 2 important sites. So this enzyme is an enzyme which has 2 important sites. One is the anionic site, and the second is the esteratic site. Now this anionic site, it possesses the glutamate residue. Glutamate, because it's a protein or it's an enzyme, so it possesses a glutamate residue. And in the esteratic site, there is a serine, there is a histidine, and imidazole ring. Now, imidazole group of histidine accept a proton from the serine hydroxyl group. This is the hydroxyl group of the serine. So, in this imidazole group of histidine accept a proton from serine hydroxyl group and creating a strong nucleophilic area, making this area a strong nucleophile. Now, anionic site of the enzyme, this anionic site of the enzyme bind with the quaternary nitrogen of acetylcholine, quaternary nitrogen of the acetylcholine, and through the ionic and hydrophobic forces. Now, this activated serine, which is now a strong nucleophile, attack on the carbonyl carbon of the acetylcholine, carbonyl carbon of the acetylcholine, this one, resulting into a tetrahedral intermediate. And then this tetrahedral intermediate in the transition state, when it reached, it resulted in serine acetylation and loss of the free choline. This is how this enzyme works. Now, these indirect acting cholinomimetics, they resemble to the acetylcholinesterase. So, these drugs which are structurally resemble to the cholinesterase enzyme and have greater affinity for the active sites, which result into a temporary inhibition of the enzyme. So rather than working as an acetylcholine, we bring those drugs which works as a acetylcholinesterase, right? They resemble as a acetylcholinesterase enzyme, and they have greater affinity for the active sites, right? Where these acetylcholinesterase work on these sites. So that's why it works as a temporary inhibition of the enzyme, and then acetylcholine works in the same way. So this is how these indirect acting cholinomimetics works. These are of two types. One is carbamates and second is organophosphates. Okay, now first discuss the carbamates. So this is the structure of the general structure of the carbamates, where there is a R1, R2 and R3, and R1 and R2 is maybe hydrogen or some alkyl groups. R3 is aromatic amine ring containing the quaternary nitrogen. Now the example is the neostigmine, physostigmine and pyrostigmine. These are the structure. This is the physostigmine and neostigmine and pyrostigmine bromide. So just let's discuss why I have written pyrostigmine bromide, because there are some drugs which exist in the salt form. And why do some drugs exist in the salt form? Because 50% of all drug molecules in the market, they exist as salt in the form of hydrochloride, sodium or sulfate salt. Why? Because they are formed as a weak acid or base, and these drugs form is always not optimal for the dissolution or absorption into our body, and without absorption a drug cannot have a therapeutic effect. So some form require a salt. While many medication need to be water soluble too, therefore drugs are often chemically made into their salt form to enhance how the drug dissolve or boost its absorption into our bloodstream and increase its effectiveness. So that's why these drugs, they are be used as a salt form. Now the physostigmine. Physostigmine is a tertiary amine, and it is an alkaloid obtained from the calabar bean of West Africa, Physostigma venenosa. It is a reversible inhibit acetylcholinesterase, and it is available as physostigmine salicylate and physostigmine sulfate. It is a colorless, odorless, crystalline solid, and it is slightly soluble in alcohol, ether and water, but freely soluble in chloroform. It decomposes on exposure to air and light, and hence it should be stored in airtight container protected from light. Now how it works? It stimulates the muscarinic and nicotinic sites of the ANS, autonomous nervous system, and nicotinic receptor of the neuromuscular junctions. Now this physostigmine is used to treat the glaucoma and atropine intoxication. Now neostigmine. The neostigmine, same, the reversible cholinesterase inhibitor, and it is available as a bromide and methyl sulfate salt. It is colorless, or maybe it's white color, and odorless crystalline powder. It is soluble in water, alcohol, and ether, and it must be protected from light like the physostigmine. Now, how it is synthesized? It is synthesized from 3-hydroxy NN dimethyl aniline, which is a precursor for it, and NN dimethyl carbonyl chloride. This 3-hydroxy dimethyl is also known as 3-dimethyl aminophenol, which when reacts with N-dimethyl carbonyl chloride and forms the dimethyl carbamate, which on subsequent alkylation in presence of dimethyl sulfate form the desired compound. Now, it is used to treat the myasthenia gravis. Myasthenia gravis is a neuromuscular disease, which is the weakness of the muscles. It is also used to treat the constipation and urinary retention, and it is available in the form of injections. And with injection it works within a 30 minutes and lasts for up to 4 hours. And this is the world safest and most effective medicine needed in the health system, neostigmine. And why it is neostigmine? Basically, the name derived from the neos means new and stigmine from the physostigmine. So it's a new physostigmine. That's why its name is neostigmine. Now, pyridostigmine. This pyridostigmine is used to intensify both the nicotinic and muscarinic effect, and it is a reversal of neuromuscular junction blockade, and it is slowly hydrolyzed by acetylcholinesterase, then the acetylcholine, and it is used for the treatment of the myasthenia gravis. And this pyridostigmine is available in bromide salt, and it is a white deliquescent crystalline powder having a characteristic odor and bitter taste. It is soluble in water, alcohol, chloroform, and it should be stored in airtight container and protected from light.